video on changing a fraction into a decimal. So we want to be really good at changing fractions into decimals, working with fractions, working with decimals, going back and forth, vice versa. Just because we'll handle all sorts of types of numbers as we do algebra and all sorts of other math types of problems. So here I got four fractions for you. Got 5/8, we got 20 25ths, we got 16 18ths, and we got 13 33rds. So we're going to talk about how to do it. It's actually pretty simple. Some teachers may teach you to go about using this long division method, but to be honest, calculators are everywhere. All phones have a calculator. The easiest way to change a fraction into a decimal is just to punch it in your calculator and divide it. So let's go through some examples and see what happens when we do that. So I'm going to take, for 5/8, we do 5 divided by 8. You can think of a fraction as a division problem. And what you get is 0.625, which makes sense because 5 is less than 8, so my number should be less than 1. In this case, we get 0.625, and it stops. This is an example of a terminating decimal. It has an end. It goes 625, and we're done. Boom. Take 20 divided by 25. If I do 20 divided by 25, the decimal that I get is 0.8. So it's even nicer than the other one, right? Only one digit. So it's also an example of a terminating decimal. All right, now let's look at 16 divided by 18. If I punch that in, 16 divided by 18, my calculator gives me 0.8888888, and probably end up with this little random 9, right? So here's where I really want to help you understand what's going on. This is an example of a repeating decimal. So in theory, your calculator only stops at 9 because it's programmed to. It's only programmed to go a certain amount of digits, typically 8. Some bigger ones can go more. But a repeating decimal, in theory, would never end. If I had the biggest supercomputer in the world, it could be crunching indefinitely to digits of 8, 0.8888888, on and on forever. It repeats. It's kind of weird to think about, huh? But anyways, what we do is, here's what not to do. So students will say, well, okay, well, let's call that 0.9, we'll round it. It is not equal to 0.9. It is not equal to 0.88. I can't just do a couple digits and call it good. 0.88 is a different number than 16 over 18. It's not the same thing. So I can't just round it and call it good. I can't round it and think it is pretty good. We actually do have a way to write that number exactly. So we can say, we look for how many digits are repeating. So it looks like it's just 8 is doing the repeating. I say, well, that's equal to 0.8. I put a little line above the 8 indicating it's a repeating 8. It's going to go on and on and on forever. So if you want to turn 16/18 into a decimal, then you better write it as 0.8 with the little repeating symbol above the 8, indicating, yeah, that's an 8 that goes on forever. Here's another example of repeating decimal. Take 13 33rds. If I do 13 divided by 33, it's kind of an even more interesting case. You get 0.393939939, and it goes on and on in that pattern for forever, right? So if I want to write that as a decimal, again, I can't round it, I can't do weird things to it. I'm looking for how many digits repeat. In this case, we have 39 is the repeating. And then it repeats another 39. So that would be equal to 0.39, and the 39 is the part that repeats. Okay, that's a hopeful, good introduction, a good tutorial for you as you're learning how to take a fraction and turn it into a decimal. Sometimes we have decimals that terminate, for example, these two. Sometimes we have decimals that repeat and they go on and follow a specific pattern.